Hello everyone, I am Aman Pandey, a third year engineering physics student of IIT Roorkee. Today I am going to explain you the experiment which involves studying the performance characteristics of a speed measurement trainer using the electromagnetic pickup. So I will first go on with the apparatus. So here is the speed measurement trainer kit. It consists of a basic circuit which has a power supply, a 1 Hz clock for the counting purpose, a wave shaper to shape the wave in rectangular form, a multiplier so that we can give the output in terms of revolution per minute, and then a counter to facilitate the counting of the uh, waveforms. And there are two buttons here, a push to count button which we can use to observe speed after changing this switch to the speed one. If there is as you can see here, there is already some entry, so we can use the reset button to reset that entry, and then we can use this push to count however number of sleds the motor goes. So explaining about the motor, here we have the motor which is a 15 slotted disc, and in front of it is a proximity sensor which detects if there is a slit in front of the motor or not. If there like we can see, if I manually change this, and there is an oscilloscope which we can use to analyze what waveforms are coming from the revolution of this motor. So if I manually rotate this disc, we can see that the oscilloscope sometimes goes high and sometimes goes low. That's because of the proximity sensor catching the data wherever the slot is in front of the sensor or not. If it is in front of the sensor, it is in the low state like here, and if it is in front of the edge, it is in the high state like here. So whenever we will use power supply to rotate the motor, and then it will generate a waveform of highs and low in the same manner, and we can then use the wave shaper and multiplier to count the RPM. To adjust the voltage, we can use the knob here, and the voltage is displayed on this multimeter here. As we can see, it currently displays some value near to 0. So we can now start the experiment. We would first start with changing the power supply, and it clearly shows, and we will rotate the knob till the motor starts to rotate. So it will have some. So we will start the experiment by rotating the knob to change the power supply till the motor starts to rotate. It will have some inertia, so it won't start rotating until upon some value, and we can see that value in the digital multimeter. So we will slowly rotate till it goes to that value. And as we can see, the motor has started rotating at values approximately 1.55 volts. So this is the power supply needed to start the motor, and we can already see that the oscilloscope is showing some waveform of frequency 121 Hz. So this is number of counts in one revolution. But now to calculate RPM, we need to change this quantity into number of revolutions per minute. But now to calculate the RPM, we need to multiply the wave shaper by some quantity. So we will need to change the connection from the wave shaper to the multiplier one, and as we can see, the quantity already has multiplied by 4. The frequency was initially 120 or something, and now it is 460 around. So it's approximately multiplied by 4, and the frequency given here is 460 Hz. We can also, on the 4-digit display, we can also see the RPM. It is also around 465 or 466. So that's the RPM mentioned here. So yeah, that was all about the experiment. So as the disk contains 15 slots, the number of slots in one revolution is 15, and to multiply to convert it to RPM, we need to multiply this quantity by 4 to make it 60, and thus the multiplier uses a factor of 4 here. We can see clearly that the wave shaper output is 115 or something, and then if we transfer it to the multiplier, the connecting pin, then the frequency is 460, which is exactly 4 times the wave shaper output. So that was it for the RPM measurement. We can also do one experiment for speed measurement. We can transfer this speed to this switch to speed, and then reset the counter, so that the counter is now set to 0, and when we are ready, we can start a timer on our smartphone and smartphone or any clock, and then we can just press the push to count button. Till the push to count button is pressed, it will count the number of slots pass through the proximity sensor, and once we release this push to count, we have the number of counts passed till now, and as we have recorded the time this button was pressed, we can use this to calculate the speed of the rotor. So yeah, that was all for the experiment. So we need to take some precautions while doing this experiment. The connecting wires are delicate, so we need to make sure that we don't disturb them too much. Also, the power supply knob here, if we increase the power supply to the maximum, the motor will start making some sounds and move on its own, and this is an indication that we should not increase the power supply beyond the limit. It's around 4.5. It will be around 4.5 and 5 volts, etc. So yeah, that's all for this experiment. Thank you.